I'm a chief designer of this vehicle and also the project manager of the parts wheeled armored vehicle programs. This is our new products, the parts family. The reason of that, why we are designing this type of vehicle to make the special purpose missions on the Turkish Army requirements. We want to make an amphibious and low silhouette our vehicle on the design. So if you look at the designs, main difference is power pack locations. When you think about the amphibious operations, the balance of the vehicle is very critical. So to make the safety operations on the water, you have to consider everything on the power intake and on takeoff. And so the engine is located in the rear, and the 5% is inside, located in the inside. The main difference is amphibious capabilities. You know, if you look at the FNX, this type of requirements maybe they don't have, but the vehicle is not amphibious. And also the crew members in the inside. The 5% in the inside, and in the FNX, I think 3 persons, only 3 crews available. The mobility performance is very important for us. When you look at the topology of the mobility design, break-off angle, departure angle and approaching angle is very high when compared with the other competitors. We have a chance to implement a different type of weapon systems also. This one is Aselsan products 12.7 machine guns, remote weapon stations that are controlling the inside of the vehicle. When you look at the mobility performance, most critical subsystem is suspensions. Suspensions and drivetrains must be designed according to your requirements. When you look at our suspension systems, we are using the independent double wishbone systems and with the high wheel travel. And so if you look at the size of the tire and width of the tire, we select this tire to reduce the ground pressure on the field, on the off-road especially. There's some run flat system is integrated. CTI system is also integrated. The suspension can be called spring or hydropneumatic suspension, depends on the customer needed. I mentioned before the amphibious capability. This vehicle is designed for the amphibious operations. So it means that you don't need any preparations for the amphibious operations. So 2 water jets is installed in the rear, and so you can control this water jet systems with the joystick in the inside, and then the freeboard level is very high when you compare with the traditional design. Because of the engine locations and air intakes and air outlets locations on the vehicle. What is the advantage of this design? We are taking the air at the top of the vehicle, so it gives you more safe operation on the water. I want to talk about the layouts of the systems. If you look at this vehicle inside on the top, driver, commander, and other 3 persons is sitting in behind. If you look at the rear of the sections, there's some stowage area. We can install the ammunitions, we can install the mission equipment, we can install the camera systems or auxiliary power unit in this area. Engine transmissions and transfer cases are located here. Air intakes and air outlets locations. So it gives us less signature, thermal signature on the cameras. FNSS believe that the vehicle must be designed according to missions. You have to take the missions first, and then you have to design the vehicle according to this mission to get the perfect solutions for the customer. So these missions of this vehicle is reconnaissance missions and also weapon carrier, different type of weapon system carrying. And also in the design criteria, we are always focusing on the 4 areas. One of them is mobility, another one is survivability, situational awareness, and firepower. We want to make a balance for these 4 topics. And so in this vehicle, when you look at the mobility performance, the payload capacity, ground pressure, axial load distributions, power pack locations, water operations modes, all of them is designed according to this requirement.